Greetings! This is a short video showcasing development work on my text-based adventure game, Eldoria, with a slight twist. The twist is that I'm leveraging GitHub Copilot in Visual Studio Code. Touted as an AI pair programmer, I'm going to see if I can use it to be a bit more productive in the portion of the program I'm currently working on. Now that the combat engine is largely complete, I've been focusing on adding what I've called battle actions. You can conceive of these are techniques that both the player and any enemy have at their disposal to use during combat. Keeping in mind that we want GitHub Copilot to lift some of the load here, let's first look at the anatomy of a battle action to see what's involved when creating a new abstraction of it. Here's the definition of the battle action class. It's a fairly straightforward construct, but we can give a brief description of the members shown here. First, the name member is exactly what it seems, the name of the battle action. This is also the name that's displayed in the player battle action selection window during combat. Effect is a block of code that really defines what the battle action does. All of the calculations for damage, buff, debuff, or healing effects are done here, and the result of those calculations are encapsulated in a data type and returned to the caller, which is always in the Battle Manager class. Type is the type of battle action this is, and is somewhat of a misnomer. This member is of the type battle action type, which is an enumeration defined far earlier in the file. This enumeration defines concretely the types of actions there are in the game, and sets the foundation for a rock-paper-scissors elemental system. MP cost is self-explanatory. Effect value is the base damage/effect contribution the action has. Chance represents the inherent success rate of the action. Lower values means there's a higher chance that the action will fail to execute. Finally, the description member is intended to be a snarky one-liner that summarizes the action. This description is visible in the player status screen. To give a bit more context to the battle action member discussion, here's an example of what the value for the effect member is. This screenshot illustrates what a typical template script block looks like. This one, specifically, is for physical attacks. Permutations of this template vary only by marginal degrees and are relative to the battle action types. For the most part, they all retain the same heuristics for determining how to calculate aspects like base damage, affinity and critical modifiers, augments, and final damages. Along with this, they all take the same parameters. Because of how script blocks work, the parameters need to be self-referential in the sense that the caller needs to pass itself into the function. However, we're not here to discuss the nuances of PowerShell script blocks. Finally, here's a sample specialization of the battle action class, BA Punch. This is an expression of a battle action that the player or enemy would be able to use. We can see that the base class constructor is called, and then in the superclass constructor, the inherited members are initialized to values that are relative to the intended design of the specialization. Every time I need to define a new technique, it needs to follow the pattern shown here. When defining new techniques, it's important to note that the values for MP cost, effect value, and chance require some degree of testing to ensure that their values balance correctly in relation to not just the combat engine, but with player expectations and what constitutes fair gameplay. So whatever ends up being an initialized value here may or may not end up being the value assigned after testing. Since we're only concerned at this point with getting the definitions written, it's not vital that these initializations be correct. That said, what I do expect to be correct are the values for name, description, type, and effect. These are the so-called unsaid rules that I'm looking for GitHub Copilot to augur from my code and, consequently, be able to reproduce with, hopefully, decreasing margins of error. I have enough experience with GPT now to know that virtually everything it generates should be taken with a grain of salt and, as we'll see here, the same trepidation should be encouraged with regard to Copilot. The reason I want Copilot to do this for me is that this is repetitive code that I'd otherwise have to type out by hand. Although I do have custom code snippets defined that are intended to be used for Eldoria, these grossly underperform on my computer, partially because it's a lower-end computer, but also too because with a file this large, you start to really understand where Visual Studio Code can fall apart. The time it takes for the linter and parser to catch up with symbol changes to the structure of the file means that the ability to understand that you're attempting to invoke a snippet takes longer than it would be to simply copy and paste. I can say, prior to showing GitHub Copilot in action, that in this regard, GitHub Copilot shines in terms of generating text in a fraction of the time that it would take the engine to understand that I'm trying to use a snippet. And for the smart cookies in the room, GitHub Copilot doesn't get confused if you're mixing snippets and this is demonstrated later. So, to state this clearly, I want GitHub Copilot to be able to pair program with me by helping to alleviate a truly arduous task of writing structurally repeat code blocks. Obviously, there are other ways to go about solving this problem, but why not get an AI to do it with me? Let's take a look at what happened during the test. So here's the Eldoria code. We're at the most recent battle action, BA Aqua Jet. I have a list of actions already written down in a notebook, so I'm going to add the next one in the list. It's called Title Surge. I'm going to add a fresh line break between the classes and start to type the name of the class. You can see that GitHub Copilot is already in action here, attempting to generate what it thinks the rest of the code I'm going to type is. From what we can see, the generated suggestion isn't too far-fetched from what I'd expect to be sane. To clarify, I've not explicitly provided Copilot any code to train on, and I've also disallowed it from reaching out to public GitHub repositories, a setting that you can configure when you first install the plugin. Although most of this functionality is a black box, I'm hoping that Copilot is inferring what I want to type either from having repeatedly typed the same thing within the session, or from examining my code structure to get an idea of what would come next. One important fact to note here is that when generating the text that would be the value of the type member, Copilot is able to successfully determine that the data type is the battle action type enumeration, and scope the enumeration accordingly. This, however, like other GPT-esque results, should just be taken as typical LLM output. I have had it generate nonsensical and completely non-existent enumeration values here. The values it generates for the description member are also GPT-esque. You can see with repeated generations that it's unable to generate anything remotely unique or interesting. These will have to be manually corrected later. Also, note too the values that it's generating for MP cost, effect value, and chance. Remember, earlier I said that the values these members are assigned now are not really useful since they haven't yet been tested against the combat engine. However, as part of the overall GitHub Copilot exercise, it's interesting to see what it thinks the values of these members should be, especially when you keep in mind what GPT actually does. At some point, the values it generates for the effect member also start to deviate in odd ways, but obviously in ways that are not desired. There is no prior definition that sets this value to anything other than an empty script block, yet Copilot thinks, at some point, there should be code in the braces. It's unclear what caused Copilot to think this was legal. Furthermore, the code it injects in this area is completely useless, even if it were to be left there. One other point of variance is that with the battle actions that are called something cataclysm, the name member of that specialization should contain a Unicode character followed by the word cataclysm. Copilot never really picks up on this distinction, even after multiple definitions. It, however, knows this is a variance and at some unknown cadence assigns it arbitrarily to an undesired class. At some point, it even assigns this value to the wrong member. The remainder of the video continues the demonstration until I've finished adding this batch of battle actions. I'll use this time to address some final thoughts. Copilot is a noticeably faster autocomplete method than what's possible with custom snippets, although it's not clear if it is or should be used for this case, especially given that, as we've seen here, there are issues with idempotency. At some point, you're likely going to have to smack the AI's hand to get it back into shape, and this can, in larger variances, prove to be more problematic than productive. Extending from this, it's also unclear, or at the very least from this exercise isn't obvious, if said variances correct over time and granting Copilot more exposure to your codebase. This, however, seems slightly counterintuitive given what Copilot is marketed as and what it really should be capable of doing. One would think that at the very least, it could or would take time to analyze your code structure to get an understanding of it before it starts making suggestions. If the power of this truly only comes from having public repository access, then this would be a potentially fatal flaw in the design of this product. I don't believe it's shown in this video, but as with GPT proper, I've noticed that Copilot has difficulty generating large blocks of code. It's not obvious what the number of lines limit is before it stops being able to generate code, but I know I've witnessed this before, both with GPT itself and now with Copilot. On one hand, this may seem like a non sequitur, but on the other hand, perhaps indicative of a shortcoming in the LLM. It's unlikely that I'd ever use Copilot, or GPT for that matter, to generate blocks of code that are several hundred lines long, especially given the aforementioned idempotency problems, but I'd be interested in hearing what others think about this. I have tried to use GPT to do several tasks like this in the past, with all tests yielding at the very least elementary code that I'd expect to see from a first-year computer science student, to at worst code that is criminally useless for its application context and would be torn to shreds in a code review by a seasoned programmer. Finally, I'm willing to acknowledge that by using PowerShell, I'm introducing Copilot to a programming language that it may not yet have been properly trained with. Furthermore, I'm using PowerShell for an application that it really, truly, and seriously wasn't designed for. Microsoft provides upfront documentation that calls out the programming languages which Copilot is strong with, and PowerShell isn't on that list. That said, C# is, and there's enough overlap between PowerShell and C# that it should at least be able to handle fundamental language syntax and grammars. That said, we're still dealing with an abstraction of a LLM, so it still leaves the question of why wouldn't it be at the very least a little better than what it does now. That wraps up my small demonstration of GitHub Copilot, as it pertains to my use case. Thanks so much for watching, and have a great day.